Boop boop be doop. Okay, this screencast lesson is about determining mass if you have relative molecular mass and moles, or determining moles if you have relative molecular mass and mass. Is basically using this equation that the relative molecular mass is equal to mass divided by number of moles. Or you can think of it like looking at this triangle in the corner, where you can rearrange these three variables by covering up the variable that you're trying to find. All right, so let's aim at this question. What is the amount of H2O, the amount of water, in a 1.00 times 10 to the minus 4 gram sample of water? So again, let's identify that. First of all, when we're talking amount, we are talking about moles, okay? So let's identify that. This question is actually asking us to calculate the number of moles of water, all right? What we're given here is 1.0 times 10 to the minus 4 grams. Identify that that is a mass, okay? So therefore, we're going to use the equation in the form of moles equals mass divided by relative molecular mass, okay? We can find the relative molecular mass of H2O from your friendly neighborhood periodic table. So hydrogen is a 1.01. There's two of those. And then to that, we're going to add the mass of water, which is 16. There's one of those. So it's going to give us 18.02 grams per mole. That is the relative molecular mass of water. Okay, so then we have the mass. We're going to sub that in there. We have this. We're going to sub it in there. Just arrows flying everywhere here. So 1.00 times 10 to the minus 4 grams divided by 18.02. Pump that into your calculator and you'll get 5.56 times 10 to the minus 6 moles. So in a 1.0 times 10 to the minus 4 gram sample of water, that represents 5.56 times 10 to the minus 6 moles of water. Next question, what is the mass of 1.00 times 10 to the minus 5 moles of NH3, which is ammonia? Okay, so this time we are given the number of moles. That should be fairly apparent because you can see the unit is moles, and we're being asked for the mass. So we're going to have to use this form of the equation. Mass is equal to moles times relative molecular mass. Let's determine the relative molecular mass of NH3 from the periodic table. So there's 14.01 for the nitrogen, and each hydrogen is 1.01, right? So that's 3.03 for a total of that. Looks about right. Grams per mole. I can almost fit the unit in there properly. Kinda, sorta. Yeah. Okay. That's a decimal. All right, so then we sub that guy in. And we're going to sub this guy in. And we're going to get 1.00 times 10 to the minus 5. Get your calculator fired up. Get it ready. We're going to multiply 17.0. And what are we going to get? 1.70 times 10 to the minus 4 grams. That is the mass of ammonia in that given number of moles. Hope you found that helpful.